Good afternoon all. This is Tesh Kumar, Assistant Professor of EC Department. And now let us see the another video lecture series on linear time invariant continuous time systems. That is nothing but impulse response and frequency response. See, this is the empathy of impulse response. First, we can apply a short pulse and then analyze the results that can record the output and connect math to the signals. What are all the challenges means apply a very short pulse and recording the resulting the output. Small noise in the input or output can cause large errors, especially for higher order or unstable system. Hard to connect math to real world signals. Next one, frequency response. You can measure the output to sinusoidal inputs at various frequencies. Apply an unit impulse or Fourier transform to get the output. Practical measurements use pseudocode random sequences or sine sweeps. Next one, impulse response. See, impulse response means when the unit impulse is applied to linear time convolution sequence, we can get the output as h of t. In terms of system reaction, the output when the system input is continuous or discrete. Time domain analysis represent the system reaction over time to an impulse. Output prediction enables prediction of output for any input via convolution, fundamental in time domain system analysis. Next one, frequency response. How to maintain the cycle in terms of frequency response. First, we can going to derive the Fourier transform and to characterize the system and can analyze the frequency components of the signal. The frequency response describes how a system amplifies or attenuates each frequency component expressed as magnitude and phase versus frequency. Derived as Fourier transform of impulse response used for frequency domain characterization. And then the ideate impulse response. Impulse response is the output generated by the system when the unit impulse is applied at the input. X of t can be applied is equal to del of t can be applied to linear time invariant system which can produce as output y of t is equal to h of t. See, unit impulse is defined as del of t is equal to 1 for t is equal to 0, 0 for t should be not equal to 0. How to represent in terms of frequency response? H of omega is equal to y of omega divided by x of omega, a ratio of the output to the input. Next one, Fourier transform. How to represent the Fourier transform? With the help of time domain analysis, we can convert from the time domain into frequency domain. Then by applying inverse Fourier transform synthesis function, the frequency domain analysis is converted into time domain sequence. Therefore, S of f is equal to Fourier transform of S of t. S of t and S of f forms the Fourier transform pair. Next one, how to represent in terms of Laplace transform means first signal transformation. We can give the time domain analysis that can be converted into frequency domain. For that, design applications we are applying to design applications. See, first differential equation, we can apply the Laplace transform and then algebraic equation solving for roots. We can find the applying the inverse Laplace transform, we can get the impulse response of the system. Next one, applications. It is used in audio systems, control systems and signal processing. See, audio systems means characterization of room acoustics and speaker response in sound engineering, understanding transient behavior in feedback and automation systems, signal processing design and analysis of digital and analog filter for various applications. Next one, prototyping, designing filters with the desired passband and stopband characteristics, stability analysis in control systems using Baud and Nyquist plots, audio equalization and distortion minimization in sound systems, simplifies analysis of cascade systems via multiplication of responses. Next one, we can check the output by concept checks. We can concept equation that can be applied to concept checks, and finally we can sketch the h of j omega, that is nothing but y of omega divided by x of omega with the help of system response. Output y of t is equal to x of t into h of t. It can be defined as integral over x of tau into h of t minus tau into d tau. H of j omega is the Fourier transform of h of t. See, Fourier transform pair with h of j omega. That is, h of j omega, magnitude of h of j omega tells how much each frequency is amplitude. The phase response of h of j omega tells how much each frequency component is shifted in time or phase. Now we can see the assessment. Define impulse response. Impulse response means the unit impulse is applied to linear time invariant system which can get the output as impulse response. Frequency response is given by h of omega is equal to y of omega divided by x of omega. List the applications of impulse response. It is used in system characterizations and then biomedical applications, etc. Define unit impulse signal. See, del of t is equal to 1 for t is equal to 0, 0 for t should be not equal to 0. Fourier transform provides effective transformation link between time domain and frequency domain representation of the signal. List the steps to find impulse response of the system. First, for the differential equation, we can apply the Laplace transform and then solving for roots, algebraic equation, and taking the inverse Laplace transform, we can get the impulse response of the system. Thank you.